This tutorial video is about proportions within triangles. So all we're going to do here is do 3 examples, one of each type. This first example is referred to as the side splitter theorem. If you have a triangle and a line is parallel to a third side, then it splits the sides proportionally. To solve these, it is all proportions. So I like to do left over right. So 5 over x equals, and I want to follow the same pattern. I started left and went towards the right. Start at left, go towards the right. So 5 over x equals 10 over 30. Cross multiply, 5 times 30 is 150 equals 10x. Divide by 10, and my answer is 15. Now, that is not the only way to set these problems up. So let's go ahead and set it up a new way. I can also go top to bottom. 5 over 10 equals top to bottom, x over 30. So 5 times 30, again, 150. 10 times x, 10x. My answer stays the same. So there's a couple ways to set all of these problems up that we're about to do. Let's do another one. You can do this another way. Okay. You can also go bottom to top, 10 over 5 equals 30 over x. Again, same type of problem. 10 times x is 10x. 5 times 30 is 150. Dividing by 10, I still get 15. The other way you can do this problem is right to left. Let's grab another pen here. So I could also go x over 5 equals 30 over 10. As long as I'm going the same direction, I'm going to get the same answer. So this pattern will work on any of these problems that we're about to do. Again, I'm always going to go left to right. It's just a little bit easier, but if you draw the arrows, as long as your arrows are going the same direction, you're setting the problem up correctly. So let's try the next one. This is a corollary to the side splitter theorem. Instead of it being a triangle, now it's just 3 parallel lines. The patterns stay the same. I'm going to go left over right. So 15 over 25 equals 6 over x. I'm going to cross multiply. 15 times x is 15x. 25 times 6 is 150. So when I divide both sides by 15, my x value is 10. Now I can exactly do what I did up above if I wanted to. So again, I could go top to bottom, top to bottom. I would be getting the same answer. So just know with proportions, there's more than one way to set the problem up. That just because you're setting it up differently than the person next to you doesn't mean you're setting it up wrong. It just means that you're doing another solution path. The best way to know if you're doing it right is if you're drawing your arrows, they should never cross, meaning they can never make an X. If they do, that means you're setting the problem up wrong. Think of the X as in like, no, don't do that. Like if it crosses, you're setting it up wrong. It's making an X to tell you it's wrong. So these should be going the same direction. The last one is the angle bisector theorem. So what happens here is you have a ray or segment that bisects an angle. The way I want you to envision this is one triangle here and one triangle here. You need to be able to see 2 different triangles. Again, there are 4 ways to set this problem up, but I find it easier if you stay within the triangle. So to start, I'm going to do the big side first over the small. Big over small. 28 over 7. And I'm going to follow that pattern on the other side. 20 over x. Now, you don't have to do it that way. I can, again, do 20 over 28, x over 7, but I find it's easier to kind of remember if you stay within one triangle. So I do full side over small side. So 28 over 7, 20 over x. And again, I'm going to cross multiply. So 28 times x is just 28x, and then 20 times 7 is 140. dividing both sides by 28 gives me a length of 5. And again, I could do exactly what I did up above, set up 4 different proportions. I should get the same answer. And again, these lines should never crisscross and form an X. Think if it makes an X, it's telling you it's wrong. And these are proportions within a triangle.